Here are the solutions for Chapter 14 on scope. This is scope.c. This is the program I'm going to use to solve the exercise on how to get three variables visible in the same place, or at least theoretically visible in the same place. There's a few ways of doing this. This is the way I've chosen to do it. We've got one variable called x, which is set to 100, which is a global variable. We've got another variable called x, which is set to 200, happens to be a float, which is a different type to the first one. And we've got a third variable inside a block, inside the function, which is also called x, and it's set to 300. And theoretically, at this line of code here, we don't know which of the three we're going to get. Well, we do know, because we know what the rule is. But if we didn't know any better, we might not know. The compiler knows, we might not. Before I run it and see which one we're actually going to get, what about this line of code? If x is greater than 150. Now, that's going to be interesting, because x is either going to be set to 200 or it's going to be set to 100. So which is it? Are we even going to go into this if code at all? It's a good question. Okay, so I guess the answer is going to depend on what happens when I run the program. No errors, and run. The value of x is 300. Okay, 300, let's remember that. Why would it be 300? Well, remember our rule that says if you're in here and there's some ambiguity about which x you should be choosing, then you choose the one with the smallest scope. And this is the one with the smallest scope. Okay, so that's the rule. Here we have another call to x. Now, which x is it going to use here? Is it going to use this one, or this one? Well, it's never going to use that one. That one's not even visible at this particular point. It might look like it is, but it's not. That's in a sub-block, and that sub-block has not yet been created. Not at this point anyway, not while we're about to test out this particular condition. So it's either going to be this one or this one. So if there's ambiguity, again, you go with the one with the smallest scope, and that happens to be this one. And that is 200. So 200 is greater than 150, so we do go in here and do the printf. Okay, so that's scope.c. Let's have a look at the second exercise on two functions that have the same name. Again, I've got another little project here with two files in it. It's called static. This isn't the one in the chapter folder, this is the one in the solutions folder. Here is static1.c, and we have a function in here called initialize. It's a static function, and it sets the value of count, this global variable here called count, to 100. Now, the main calls that initialize, and then calls another function called func. Let's go and have a look at that other function called func. That's in static2.c. Okay, here's static2.c, and here is the func that gets called from main. And what does it do? Well, it simply calls a function called initialize. Oh, another function called initialize, which is up here, and it's also a static function. And this one sets count to be 200. And count, in this case, is not the global variable called count, but it's a local static variable called count. So, we have two functions, both called initialize. Here's one of them, and the other one is in static1.c. This one sets count to be 200, and this one sets count to be 100. So we call this initialize first, and then we call func, which we'll call the other initialize, which sets some other count to 200. And finally we print out the value of count. What's it going to be? Can you guess? Okay, well, let's run it and find out. Compile first. No errors. Run. The value of count is 100. You probably expected that, right? So why is it 100? Well, certainly the other initialize does get called, but it doesn't actually modify this version of count. It modifies the other version of count. Anyway, that's not really the point of the program. The point of the program is to show that there are two functions both called initialize. This one is a static function, and the other one is a static function as well. So the only one that is visible from this point in the code is this one. And now in static2.c, the only one that is visible from this point in the code is this one. So no matter, it actually depends on where we call initialize from as to which function we're going to get. That can be quite confusing. So can you think of a reason that this might be used? Well, let's say we've got a large scale system development going on, and we've got two programmers working for us, Bob and Harry, and I say, Bob, I want you to work on the screens subsystem, the menuing. I want you to be responsible for the user interface. And Harry, I want you to be responsible for the database. And they both go off and they don't talk to each other, and they come up with a fully working set of functions. However, they've both got a function, they've both written a function called initialize, unbeknownst to each other. They didn't collude on this. So what do? Should one of them rename his function? Well, he doesn't have to. In fact, it doesn't even matter. As long as those initialize functions are static, as long as the main part of the program doesn't need to call either of them directly, then it's fine. This happens so often in C programming, especially in large-scale systems. It's just simply too difficult to keep track of different function names and making sure that every function that you create has got a different function name to every other function that you've ever created. If you want to create a little function somewhere that does some little menial task, you can call it anything you like, as long as you make it static. In fact, you should make every single function static if you can, except for the ones that represent your, if you like, public interface to the functionality that you're providing. For example, the guy who's doing the database, he might want to simply offer up the functions called read a record, write a record, search for a record, delete a record. Those might be the only functions that he wants to make available. However, he might have actually written 60 different functions that help accomplish those 4 tasks. Now, those other 56 functions, he can call them whatever he likes, because they are not part of the public interface to his database routines. He can do that. He can call them whatever he likes, as long as he makes them static. That's the important thing. So make as many functions as you can static, obviously except for the ones that you want other people to use. Finally, let's go and have a look at our course project. Okay, here's main.c. Now, this line of code is the only change that I've made. Now, this line of code used to be just down here inside the main, but I've taken it out and put it outside the main function and made it essentially a global variable, but it is not a true global in the sense that it can only be accessed inside this particular file. Why? Because I've got the static keyword there. This program still works. It still compiles and it still works. How do I know that? Well, I can prove it to you, but I think you'll just have to take my word for it. Try it yourself. You probably already have tried it yourself. You might be wondering to yourself, surely all the other functions like read a CD and write and print a CD, surely they need to have access to this array as well. Don't they have to have access to this array? Aren't they in fact reading and printing the elements of this array? Yes, they are. But you'll recall that we actually pass them the parameter, meaning the CD that we want them to print. They don't actually have to know the entire array, they just have to know about the one that we're wanting them to deal with at that particular moment in time. And when they need to know it, we'll tell it to them. They don't ever need to see this array. And the fact that this program compiles and works means that must be the case. Okay, that ends the chapter on scope.